Alright, so for this problem we're asked to find points of inflection for this function. It's f of x equals x to the fifth plus 5x to the fourth minus 100 over 3 x cubed plus 7x minus 15. The first thing we're going to do is find the derivative of this function, which is f prime of x, and then just find the derivative term by term just like normal. Alright, so that's 5x to the fourth plus 20x cubed minus 100x squared plus 7. The next thing we're going to do is take the derivative of this function, which gives us f double prime of x. It's going to be 20x cubed plus 60x squared minus 200x. Alright, now to find a point of inflection, we want to set this equal to 0, because remember, at points of inflection, the second derivative of the function is 0. And you'll notice that all these terms are divisible by 20. To make the math a little easier on us, we can divide this whole side of the equation and this side by 20. And of course 0 divided by 20 is still 0, so we don't really have to do much to this. It doesn't change the answer, it just makes it easier to solve. So we'll have x cubed plus 3x squared minus 10x, and that's equal to 0. The next thing you'll notice is that there's an x in each of these terms, so we can bring that out. We don't want to get rid of it completely like we did the 20, because it'll help us find one of our points of inflection. So just bring it out to the side. We still have x squared plus 3x minus 10. You'll notice that you can factor this as well, so we'll go ahead and do that to find our points. Alright, so now we want to find what makes each of these three terms equal to 0, which will, in turn, each of those will cause this whole thing to be 0, which is what we're looking for. So the points that will do that are x equals -5, x equals 0, and x equals 2. Notice a -5 here will make this term 0, a 0 here will make this term 0, and a 2 here will make this term 0. So now we have our possible points of inflection. What we want to do is choose points on either side, both lower and higher than each of these, to figure out if the sign changes at these points. Because at a point of inflection, the sign of the second derivative is supposed to change. So move this up some. The points we're going to try are -6, -1, 1, and 3. Notice the -1 is between -5 and 0, and the 1 is between 0 and 2. And instead of these points, I could have used -7, -2, 1.5, and 5 million. I mean, it doesn't really matter as long as this point is in between these two, this is in between these two, this is less than -5, and this is greater than 2. So let's start out with -6. We're going to find f double prime of -6, and it's not really necessary, but just to be safe, we're going to include the 20 from this part, but we're going to use this expression for f double prime of x to make it a little bit easier to solve, because we don't need to know exact numbers, we just need to know if it's a negative or positive number. So 20, and then I'm going to start using this. X is -6, so -6 times -6 plus 5 times -6 minus 2, and that is going to be equal, actually let's move it down here, sorry I'm running out of space horizontally. That's going to be 20 times -6 times -1 times -8, which is 20 times -48, and that is negative. Alright, it's less than 0. Next we're going to try f double prime of -1. So we'll get 20 times -1 times -1 plus 5 times -1 minus 2. Bring it down here. 20 times -1 times 4 times -3 is 20 times 12, which is positive. Okay, so the sign of f double prime of x does change at -5 because the points on either side of it change sign. So now we can try, so this is confirmed. Now we can try 0. I'm sorry, 1 to test 0, because we already know this is positive. So for 0 to really be a point of inflection, f double prime of 1 should be a negative number. So 20 times 1 times 1 plus 5 times 1 minus 2. It's going to be equal to 20 times 1 times 6 times -1. 20 times -6 is negative. So that's also confirmed. Now we just got to find f double prime of 3, and we'll be good to go. That's going to be 20 times 3 times 3 plus 5 times 3 minus 2, which is equal to 20 times 3 times 8 times 1. It's 20 times 24, which is positive. So we see all three of these are confirmed. So our points of inflection are x equals -5, x equals 0, and x equals 2.